Hi guys, this is Viha from SVC. My USN is 1V22IS059. Today we're going to talk about additional list operations, sparse matrices, and doubly linked lists. So what are list operations? Any operations that can be performed on a given list is known as list operations. They can be of four types: traversing, searching, insertion into the linked list, and deletion from the linked list. So what is traversing? Traversing refers to accessing each element of the linked list. This allows us to read every element in the list. Traversing can be done only in one direction. Traversing can also be used to print elements in the given list. Traversing algorithm uses a pointer variable PTR which points to the node that is currently being processed. Now pointer pointing to link points to the next node to be processed. So here is an algorithm for traversing. We set PTR equals to start. We repeat steps 3 and 4 if and only if PTR is not equal to null. Apply process to PTR pointing to info and set PTR equals to PTR pointing to link and then exit. Let list here be the linked list in the memory. This algorithm traverses list, applying an operation process to each element of the list. The variable PTR points to the node currently being processed. Here's a code for the traversal of the node. Next is searching. Searching, as the name suggests, we use this to search for a particular element in the given list. This can be done in two different ways. The first way is to search for the element in an unsorted list where the given data is not in any particular format, not arranged in any particular format. The second way is to sort the list prior to searching for the elements and then searching for the elements. So searching is also like traversing and can be done only in one direction. Searching also gives you only the first time the element occurs in the list and does not give you the location of the element if it occurs again in the list. So searching in an unsorted list includes the following. We search for the item in list by traversing through the list using a pointer variable PTR and comparing item with the contents PTR pointing to info of each node of the list. So before updating the pointer PTR by PTR equals to PTR pointing to link, it requires two tests. The first one is to check whether we have reached the end of the list, that is by checking if PTR is equal to null. If PTR is not equals to null, then we check whether PTR pointing to info is equal to our item. So searching in a sorted list, here we search for the item in list by traversing the list using a pointer variable PTR by comparing item with the contents PTR of info or PTR pointing to info of each node of list. Searching can stop once item exceeds PTR pointing to info. Here's a basic algorithm for searching for an element. So we set PTR equals to start. We repeat step 3 while PTR is not equals to null. So if item is less than PTR pointing to info, then we set PTR equals to PTR pointing to link. Else if the item is equal to PTR pointing to info, then we set location equals to PTR and exit. Else we set location equals to null and exit. Here's a code for searching for an element in a given linked list. Next is insertion into a list. So where insertion basically refers to adding a new element to the linked list. This can be done in three ways: insertion at the beginning, insertion at the end, and insertion at the in between. So for insertion at the beginning, here's an algorithm. We check first for an overflow. So if avail equals to null, then we write overflow and exit. Next, we remove the first node from the avail list. So set new equals to avail and avail equals to avail pointing to link. So set new equals pointing to link equals item and then set new pointing to link equals start. So this new node now points to the original first node. Set start equals new, changes start to it to the new node. Here's the code for inserting in the front or the beginning of a given linked list. Next is insertion in the end. So this allocates the memory for a new node, stores the data, traverses to the last node, changes the next node of the last node to recently created node. Here's a code snippet for insertion in the end. So first we're initializing node last equals to first. and then entering the details like we did in the insertion in the beginning. Next is insertion in between. Here again, we check for overflow. If avail equals null, then we write overflow and exit. Then set new equals to avail and avail equals avail pointing to link. Set new pointing to link equals item. So copies new data into the new node. If location equals to null, then we insert at front node. Set new pointing to link equals to start and start equals new. Else set new pointing to link equals to location pointing to link and location pointing to link equals new and exit the program. Use the code snippet for including an element or insertion of an element in between two given elements. Next operation is deletion, which refers to deleting an element from a list. This again can be done in two ways, deletion from beginning and deletion from end. When a node n is deleted from the list, its memory space is basically returned to the avail list, and usually at the start of the avail list to make it easier for the programmer. So here's the code snippet for deletion from front. We're first initiating temp equals to first, and we're checking if first equals to null. So basically making sure that your list is not empty. If the list is not empty, then we print the deleted node and initiate first equals to first pointing to link and then free temp. Here is deletion from an end. So here's a code for deleting from end. So we first initialize node last equals null and temp equals first. Again, we're checking if the given list is empty or not. So first equals to null. If it is true, then the list is empty. If it is not, then we check if first if pointing to link is equal to null. If it is, then we delete the element that is %n/n temp pointing to USN. Free the first and first equals to null. If first of link is not pointing to null, then we execute the while loop. Last equals to temp, temp equals to temp pointing to link, last pointing to link equals null, and free of temp. The next topic is sparse matrices. Sparse matrix is a matrix which basically contains more zero elements than non-zero elements. So it can be defined as a two-dimensional array. An array with m rows and n columns represents a m into n matrix. There may be a situation in which a matrix contains more number of zero values than non-zero values. Such a matrix is known as a sparse matrix. Sparse matrix is a matrix which contains very few non-zero elements. So what are advantages of sparse matrix over a simple matrix? The first one is storage. There are lesser non-zero elements than zero elements, thus the required memory space is less compared to in a simple matrix. Next is computing time. Computing time can also be saved by logically designing a data structure traversing only non-zero elements. So if you're not traversing through the multiple zero elements that are present in the matrix, we are actually saving computing time. Next is representation of a sparse matrix. This can be done in two ways. One, using triplet representation, which is nothing but array representation. Next is linked representation or single linked list representation. So in triplet representation, the 2D array is used to represent a sparse matrix in which there are three elements. Basically, row, that is index of row where non-zero element is located, column, that is index of column where non-zero element is located, value, that is value of non-zero element located at the index of row and column. Here's an example for the same. So as we can see in the first row that's pointing to 0, column is 2 and value is 3. That is basically the first non-zero element in the given matrix on the left-hand side. Next is single linked list representation. In linked list, each node has 4 fields again. Here the 4 fields are as follows: row, index of row where non-zero element is located, column, index of column where the non-zero element is located, value, that is value of the non-zero element located at the index of given row and column, and the next node of the address. So this next node contains the address of the next node. Here's an example for the same, where 0 is the row index, 2 is the column index, 3 is the value, and the node after that points to the address of the next node. Next topic is doubly linked list. So doubly linked list is a linear data structure that contains a sequence of nodes. In doubly linked list, where each node contains a value and two pointers, one pointing to the previous node of the given list and one pointing to the next node in the given list. So doubly linked lists allows traversal in both direction, forward and backward. This is possible because it contains an additional pointer to the previous node. So as you have a pointer pointing to previous node and a pointer pointing to the next node, you can traverse in both the directions. So doubly linked list also supports insertion and deletion of nodes at both beginning and end of the list efficiently. So here are few advantages and disadvantages of doubly linked list. Advantages includes allowing you to traverse in both the direction, forward and backward. It also enables efficient deletion of node without traversing the entire list. The disadvantages are as follows. It requires more memory compared to singly linked list due to the extra pointer available pointing to the previous node. It is also more complex to implement and maintain compared to singly linked lists. There are many operations that can be performed on doubly linked lists. Few of those includes insertion, deletion, and traversal. In insertion, it's basically inserting a new node into a doubly linked list, which involves updating the pointers of the existing nodes to accommodate new node. Deletion refers to deleting a node from a doubly linked list, requires updating the pointer of the adjacent node to remove the node. Traversal basically refers to traversing a doubly linked list, involves visiting each node in the list, starting from head or tail and following the pointers. Thank you. Have a great day. Please do like and share the video.